Quick question, what do you look for when you're looking at an M.2 NVMe enclosure? Are you looking at throughput? Are you looking at capacity? Are you looking at the UASP capabilities? What about trim? Does that pass through? A lot of questions we have to answer that we are curious about that we're going to talk about in this video today. Let's take a look at the listing of the product that we're going to be showcasing. And this is the Jii M.2 NVMe enclosure, USB-C, 10 gigabit, and to reiterate, it supports UASP and trim. And all those things are important. So what we're going to do is an unboxing, inspection, installation, and test. And then we're going to also go through the specs as this relates to the media we're going to put in here, as well as the system we're going to be testing on. So let's get this box open. And you can see the label, Jii NVMe enclosure. Flip this over, we've got one seal. So we're the first to be into this. Appreciate that. We'll flip it back over and get this opened up. Great. We have a lanyard, we have thermal pads, a screwdriver, we have the enclosure in the bag, and we've also got two cables, USB 3 and USB-C. And then we've got the standard documentation with a barcode that you can scan in. Let's see what's in the package for the M.2 heatsink. Nice little enclosure. Now this is the back side, and this is the side we're going to be working from. It says Jii, there's a screw to hold it down. So we have the enclosure and we have a lid, but we flip it over so that we can see the light that's on the front, and we'll plug in the cable. What I don't see is a particular easy way, and that looks like on this end where we would install the lanyard, where it looks like it's going to wrap around the mounting screw. So that's going to be our best option if we use it. Lightweight aluminum, appreciate that. Now we're only going to try one cable. We're only going to use the USB-C cable, because as this speaks to the interface, USB-C 10 gigabit, USB-C 20 gigabit, and Jii is working on a unit for that, and I want to thank them for making this video possible, by sending this device to us and asking us to look. Okay, a PCI Express 3.0 M.2 NVMe drive is capable of, well, let's go back. 10 gigabit USB-C is good for 1,250 megabytes per second. USB-C 20 gigabit is good for 2,500 megabytes per second. And if we were to put, and concerned about the drive we put in here, we can put in anything that's 2280 NVMe. But to reiterate, a PCI Express 3.0 M.2 NVMe drive will be capable of 3,500 megabytes. So anything we put in below that, we have an idea and expectation that we're going to get 1,250 based on overhead and throughput with the interface. If we get around 900 to 1,000 megabytes per second throughput on this, that's going to be great. So we'll culminate this in the end of the test, where we do the heat and the speed and put both those up on screen. Now, the media we're going to put in here, I think we're probably going to use the Samsung 980 Pro. What I want to demonstrate with this particular drive, either one of these drives, the WD Black SN850 or the Samsung 980 Pro, typically what we've had with the WD Black SN850, it runs faster and it also runs hotter. Both of these are PCI Express 4. But however, this would be probably about a second or third generation drive, meaning either one of these is good at up to 7,000 megabytes on the read and around 5,000 megabytes on the write. Okay, we're going to install the Samsung because they have some information that I think will help with definitions such as UASP. And what we're going to do is once we get this up, we're going to go to Device Manager, and I want to look at the driver being used. UASP has been around since probably about 2011, whether you were aware of it or not, and that will help us with the transfer rate versus going through USB, the bot driver, which should increase speed throughput by about 70%. So that's going to matter. But to reiterate, this drive far exceeds the expectations of what we need for this container. But it's what we've got. It's a 1 terabyte, and the capacity for this is a 2 terabyte drive, which I was kind of surprised is the chipset. We can look on the spec sheet. It tells us the chipset. All we need to know, suffice to say, UASP protocol is supported, and the trim command passes through that. Now, to reiterate, the control panel that will see this, of what I've been able to ascertain, most control panels are not able to fully utilize that UASP driver to see through that, to be able to see the drive. But I want to call it up and see if it can see anything, because we're going to always need the option to be able to pull the drive, and that's why I like whether you build something like this or whether you buy something that's ready-made. If we build it, we can pull the memory out of this and we can put it back in the computer so that we can do the firmware, so that we can run trim, all that kind of stuff, because trim should be run about either once a week or at least maybe twice a month. It's an automatic process. And I'll just suffice to say trim is the command for SSDs and NVMe SSDs, and it is the garbage collection. It keeps things running smooth, efficiently, and at top performance. But it's completely different than defrag. It is optimization, but it's not defrag. We don't defrag NVMe or SSDs. Let's get this open and get this installed. Appreciate the screwdriver they included. It would be nice. Wow, that's tight. I'm going to use a larger screwdriver to loosen that with. It gives me better grip. Yeah, that worked a little better. It would be nice if this were toolless, but it's not. It would also be nice if there was a little bit better indication of how that's going to mount with those little bitty holes for that lanyard. But we work with what we've got. I would also like to see, and it's not on here or even mentioned, but the ability for the Kensington lock. I think that's something going forward they might consider on other devices. And apparently the screw stays with that, so that should just slide right back. Oh, the screw does come out. Okay, so we've got to get this to slide back. Okay, that doesn't slide back. That has to be pulled out. I used a flat blade screwdriver. And this will take, to reiterate, from a 2280 all the way down. Now, we've looked at an M.2 NVMe enclosure in the past. We had one requirement, and what we were trying to achieve was we were trying to create Windows installation media using only the Windows Media Creation tool. So we had parameters we were working with. We were using Intel Optane memory, which was of the shortest size that would fit in this container. And I point that out because that would fit in this container, but our requirements were strictly to house that smallest Intel Optane. We were trying to speed up the install process. Suffice to say, oddly enough, it worked. Our concept worked. But this time, we're looking at this for different reasons. And this one, to reiterate, supports 2 terabytes, 2280 down. Most of the drives we find are going to be 2280. And the Intel Optane memory we used before, which was a 16 gig stick, was the smallest I could find that would work with the Windows Media installation tool for that specification. Anyway, we're going to get this mounted and see how this works for us. Now I'm going to turn this around so we keep our orientation. Connector on this end, and there's the connector for the M.2 drive. And we have enough thermal pads that we can put thermal pads on the front and the back. So I think I'm going to do that, because when we turn this over to look at the light, the top side where the LED light is will be facing up, and the top of the drive will be facing down. So again, to reiterate, because of the speed throughput of the interface, I don't think heat's going to be an issue. But I've got the thermal pads. We're going to use them, top and bottom. Let's see. I'm always curious when we're using thermal pads. And there's an extra screw in the container, which I appreciate. Good to know. Looks a little different than the stock. But anyway, I'm always curious about the thickness of thermal pads provided. And these are 0.9 thickness. Good. Working from the back, about where the memory is at, and for the controller. I'm going to put one on each end first. Get my destination set. Yeah, that looks good. It looks very good. Then we can space the other two accordingly. Number 3 and number 4. That'll take care of the back side. Slide that in. Nice little click. And then that'll lock down. And there's a notch right here on this end out of the shadow where that'll just rest in and clear the screw. So we'll line this up and size our spacing for our pads. Yeah, that'll work nice. Okay. And yes, we leave the labels on the M.2 NVMe drives always. Sometimes they're there for heat dissipation, such as the Samsung has one on the back that I did not point out before we started. That's copper. And this is single-sided memory. This should work with double-sided memory. But we'd have to use something like the Sabrent, which would be adequate in this. We will be using the Sabrent in some other tests. Okay, there's our 4 thermal pads. So we've got thermal pads front and back. And that leaves us 2 spares. Now all we need to do, put that down. I'm looking at the lid on how this fits, and that's got a little bit of a hook to it on this end that rests right on the edge of the card. So when that goes down, that goes in. That should lock that in. And if you notice on this other end where the connector's at, there's a little bit of a lip right there. And that lip sticking out needs to go in and lock in, closing that space. Then that just drops right in and snap fit. Then we'll put the screw on it. I'm not going to put the lanyard on right now, but I can see it's doable, but it'd have to go on this end. I think it'll be a little bit of a, well, let's give it a shot. To mount that lanyard, it's got to go around that screw, so I'm going to see if I can hook it in, push that down, and it should just fit in those grooves right there. Yeah, and that may make it easier to pull the lid off by doing that. And now we'll get the screw mounted. The stock screw that was already on this is a Phillips. The extra screw they provide was a square head. So I'm kind of surprised. And that'll just lock that down. And with the lanyard in there, that'll make it easier than when we pull the lid off. So it's definitely going to have mobility, and that is the side where the memory's at. And then when we turn that over, it's got grooves in the edge. And when we turn that over for the top, the drive is actually upside down. And then the LED light on this end, which is where the connector's at, is going to light up when we have disk activity. Now the cable lay supply, if you're on a laptop, this is perfect. If you're on a desktop like we are, this is kind of short. I'd like a cable that would be long enough to reach up to the top of the computer. So that's something to think about. You'd have to get. And the cable is about twice the length of the drive. Give you a chance here to kind of see how that looks. I'll zoom out on it just a little bit. And it's also GI. So we're going to need to power up the computer, plug this in, and see how this is going to work for us. I'll plug the cable in on one end, and then we're going to need to plug in on a port, and I've got to figure out how we're going to get camera on that. Now we don't need to see this from the BIOS screen. We only need to see this from the operating system where we're running Windows. The test system we're using is the Gigabyte TRX40 Designaire, and we've got plenty of resources. We're going to plug this into a 10 gigabit port, and then we may turn around, since we have Thunderbolt 3 on this machine, we may plug it into that port. We should also see 10 gigabit USB-C. So we can try both ports. Let's test. Check everything out. Power on. Energize. System's powering up. Once we hear post, right to Windows. Okay, what we're going to do, I've got the drive sitting here. I'm going to plug into the port right here. And the way I'm going to do this, so that you can see it as we're doing it, I'm going to put a picture-in-picture where you can see the computer screen. In the upper right-hand corner will be this screen, so you can see me plug this in. And you can see if anything happens on the screen. A dialog box should pop up because the drive's already been formatted. And something like this in a container, whatever drive you want to use, if it's a brand new drive, then you're going to have to initialize the drive and then format it. And in a situation like this for external, it ought to be set for exFAT. But we already have it set for NTFS, and this is strictly for testing. This is not for regular use. But I want to point that out in case somebody asks. So let's see if we can get these double screens up so you can see what I'm doing while I'm talking. First the computer, then the picture-in-picture. And now we're going to plug this in and see what happens when we activate. And we should see the LED light on the drive come on, which shows we have activity. See if I can tilt that up a little bit. Yep. Okay, there we can see the drive. Now we'll take it full screen, back to just this screen. And that's some data of some files we copied off beforehand. So I'm going to close this for the minute. Okay, now we're going to check the driver. So we're going to go down here to the Start menu, right-click, go up, Device Manager. We're going to go down here to Storage Controllers, and if it wasn't under Storage, then we look under Universal Serial Bus Controllers. But to reiterate, under Storage Controllers, where it says USB Attached Mass Storage Device, double-click on that, go over here to Driver, click on Driver Details. And that says UASP Store, which is correct. That's what we want. So that's something anybody can check on their computer. Even though the device supports it, we need to make sure that we have that same support through the chipset on the motherboard, which we do. And again, to reiterate, this is the Gigabyte TRX40 Designaire. And we have that 110 gigabit USB port. Now I'm going to take now and plug it in over to a Thunderbolt port and verify the same thing. So I'm going to go ahead and back out of all that. Cancel, close that out. In fact, if we just leave the Device Manager up, you'll watch that change. So let's go back to picture-in-picture. We'll unplug. The light will go out. And I'm not worried about the data on it because I haven't been doing anything. Goes out, and then the tree should change, which it did. So now we're going to go over here and see if we can plug this into a Thunderbolt port and see if we can see that enumerate again. I'll plug it into the second one, right there. Watch it come on, the light comes on, and the window opens up again. Yep, there's the light. I've got two hands, so it's difficult to show all that at one time. I'll take that off screen and go back just to the main screen. Our secondary window popped up. I'll close that down. And looking here again in the Device Manager, USB attached SCSI UAS mass storage. We'll double click, go to the top of that, go to Driver, Driver Details, and yes, UASP Store. So we're using the UASP Store on both controllers. I'll cancel that, and we can close Device Manager. This time I'll bring up Windows Flag E. We're going to go to this PC and verify our drive. And right there's our Samsung 980 Pro on the F drive. And if I click on it, there's the data we saw that kept popping up. Now I'll close that. Now let's bring up our heat and speed test. First things first, we'll bring up hardware info. We're going to be looking at sensors only. And let's see how much information SMART passes through that chip. I have no idea if we're going to see this or not, but I'm curious. Okay, all we see on SMART is the Seagate FireCuda, where we can see drive temperature. We see the disk drive here, number 2, but we don't see any data. I didn't expect anything to pass through, but I was curious. And I'm not really as concerned about heat because we're not going to get that far. But what we can do, I'll close that out. We can still run Crystal Disk Mark, and this is Crystal Disk Mark 804 x64, 1 terabyte drive, which is drive F, 1 gigabyte test file, all. And we'll just zoom in on that. And yes, we're still plugged into the Thunderbolt port. Now that's respectable. I was expecting between about 900 and 1,000 megabytes on the read, and we're getting 1,055. That's very respectable. That UASP driver makes a big difference in maximizing throughput. According to the information that Jaya has, they say it increases throughput by 100%. I'm going to be a little bit more realistic and conservative and say it increases by about 70% over the BOT driver. And these are the kind of things that you can test with the equipment you've got. Always test and verify because your results could differ. But the goal of this is to give you some idea of a baseline of what to expect. And just in case anybody's wondering, you can still see that we're on the Thunderbolt port right here. And we can see drive activity on the light. Take it back full screen, and the test is complete, and I think that's absolutely amazing. On our read, 1,055 megabytes, and on the write, 1,054 megabytes. I didn't expect anything like that on the writes. And remember, this drive we're using is PCI Express 4, and the interface we have, which is USB-C, but this is USB-C through Thunderbolt 3, it should be good for 10 gigabit, which is 1,250 megabytes. And 1,250 megabytes versus 1,055 megabytes on the read or 1,054 megabytes on the write, that exceeds my expectations. I didn't expect that, so always test and verify. But now my curiosity up. I'm going to go back and do the dual screen. Now that we've tested, let's go back now that we've tested on the Thunderbolt 3 port through the add-in card. Let's go back and test this through the USB-C 10 gigabit port on the motherboard. We're going to need to close that window down and do that again because we're going to be on a different port. Let's bring up picture-in-picture again. We'll disconnect. We'll see the light go out. And we're going to move it down now. And now we're going to connect back up on USB-C 10 gigabit on the motherboard. Plug it in. Device enumerates. Light comes on. The window pops up. Take that full screen. Again, we'll close that. Let's go straight to Crystal Disk Mark. And we still have the drive letter F. Let's double check. Windows flag E. This PC. Yep, Samsung 980 Pro, drive F. Just want to double check. So we can close that. So over here, drive F, 1 terabyte, 1 gigabyte test file, all. And the test is complete, and that is absolutely fascinating. 1,024 megabytes on the read and 955 megabytes on the write. That I did not expect. As always, we say test and verify. So if somebody says which is faster, USB-C 10 gigabit off the motherboard chipset or USB-C 10 gigabit through Thunderbolt 3. It depends. Test and verify. You've seen the results. You've seen what we've done. I'll show you again the connection so you can see the results. You can see we're plugged in right here on the header to the motherboard. And we've got the green light activity on this. And I'll take that full screen just for a little bit better view of it. So as always, test and verify because you never know where you're going to come out. So now let's double check on trim and see if that's enabled for that drive. The easiest way is Windows flag E. We'll go to this PC. We'll go over here to the Samsung 980 Pro drive. Right click, Properties, and right here under Tools, Optimize and Defrag. We're looking for Optimize. We're going to click on Optimize. That brings us to this screen. And this shows us the drive. The Seagate FireCuda 520 is the C drive. And the Samsung 980 Pro is seen. That's the F drive. And it says, OK, 0 days since last retrim. And down here it shows Scheduled optimization on. Drives are being analyzed on a scheduled cadence and optimized as needed. Frequency weekly. And that's a default configuration, but all we wanted to do is check and verify. All this stuff you need to always test and verify. And this is the easiest way to go about it. So hope that helps. Remarkable product. Glad we have trim enabled. Glad this also has UASP. There's always more to a product than meets the eyes as we kind of get into it. But again, your results may vary. Always test and verify. Okay, one last feature we want to double check. I don't think this is going to work, but it's an issue with the disk control panel being able to see through the UASP driver. So we're going to bring up the Samsung Magician and see if it can interrogate and find the drive. And to double check, we'll go to Windows Flag E, we'll go to this PC, and what we're looking for is our drive, Samsung 980 Pro F drive. Get rid of that. Let's bring up Samsung Magician. And it sees the Seagate Fire CUDA, but it does not see anything else. So up here I will click on Retry, scan for drive information, and no, it does not see it. Just wanted to double check. Well, I was kind of curious about that. I didn't expect that to work, but now we know. Details matter, and it's all about results. I want to thank you guys for watching. Welcome. This is BuilderBuy. My name's Gil Boyd. We look forward to seeing you next video. We're out.